We're going to get our championship back. Are y'all ready? It has been pre-mixed. You ready?
Yes, I am.
Hold on a second. Woogity, 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 woogity. Because the woogities throw her off. Woogity, woogity, woogity. Bam.
Okay.
Go. Makes no sense.
It's like, it's weird that I've been on a stage solving a Rubik's Cube twice in my life. And I'm not even that good. Like,
She's showing off. Talk me up. Bam.
Hi. As you probably seen, well, as you probably can assume, I've been doing this for quite a lot of time. So I am a very visual person. So that's why we're going to talk about visualizing the impact of React Native's new architecture. So let's get started. My name is Belén Carozo. I am from Uruguay, so a 24-hour trip to get here. Thank you. I work as a software engineer at Xmartlabs. It is a local company based in Uruguay. It's like a product studio. We do consultancy. But what is actually great about Xmartlabs is that they let me use time in all kinds of weird experiments and like useless things, such as the one that I'm going to show you. Well, I think they give me time to do this. I haven't asked. Well, but first I wanted to talk about the new architecture. So as you know, because of Gant's presentation, the React Native was released in 2015, and we've come a long way since then. And one of the most important changes that has been done in the latest years to React Native was an architectural change. So you might be asking, why? What was wrong with the old architecture? So this is a pretty simplified diagram of the old architecture. So you had your JavaScript side on one side, and you had the native side on the other side. And I'm sure you can relate as React Native developers. That's how the native side looks like in your minds. Well, at least until Massen's workshop, that is how it looked like in mine. And those sides communicated through a bridge. But this bridge had some issues. For example, if you had like a heavy flow of data, you could have bottlenecks that hurt performance. Another problem with the bridge was that you had to pay serialization and deserialization taxes, because everything that went through the bridge was in JSON format. You had to parse it into JSON and then deserialize it on the other side, so that brought in a bit of overhead. And also, you had to wait for the responses from the native side, even if you didn't need it. Like, the JavaScript side always waited for an answer, even if it didn't need it. So, what changed? How was this fixed? Again, this is overly simplified. If you want to learn more about the new architecture, I recommend you take a look at the React Native official documentation about the new architecture, which is really good. But yeah, very simplified. There's an interface now that lets each side directly invoke methods on the other side. And there's also a new renderer that goes along with this, and a lot of other things you may know of. But yeah, take a look at the documentation if you want to learn more. And this improved because this got rid of the bottlenecks. This also, you don't have to pay serialization and deserialization taxes now. And you don't have to wait for an answer from the native side if you don't need it. But you as developers, right? You may be asking, why should I update? We know that we have to update, right? Right? Please tell me you do. We know that we have to, because if we don't, maybe some issues will appear in the future because of things not being maintained. We also want to gain advantage of all the new features of like the newer versions. We want to keep our code up to date. But maybe you have like a little voice inside of you, or maybe that voice is like a client or a product owner or something that is telling you, well, I mean, it can take a lot of time. Everything is working now, so why should we risk it? We don't want things to break. And surely the performance improvements won't be very noticeable. So that's what I wondered too. I wanted to see if the performance improvements were something that you could see visually, that you could perceive if you had two apps side by side, you can notice a difference. So I decided to investigate. And this is the experiment I created. I created a fight between two apps. You have, on the one side, you have the old architecture app. It was created using React Native 0.68. That's because I wanted to have everything that surrounded that version, not only like the new architecture turned on. And you have on the other side the new architecture, which has a version of React Native of the 0.74.2. But other from that, both apps have exactly the same code, even the same compiled SDK versions, target SDK, everything else, I try to keep the same. And I decided to test this on a Samsung J3. I don't know if you have used this. I don't know if this phone even made it to the US, to be honest. But it is a pretty bad low-end Android device that came out in 2018. So you can imagine how bad it is. And that's going to be our ring, right, for the fight. And why? Because I wanted to, well, first of all, I thought that the performance improvements, if there are any, would be more noticeable in a phone that really suffers from performance issues itself. And also, there's like a big segment of your users that are not using the latest iPhone. They are using lower-end Android devices, and you want to give those users a good experience too, right? I created some app features that I'm going to compare for this fight. We'll get more into each of these. And this is something important. There are already a lot of benchmarks on comparing the old architecture with the new one. And I wanted to test, as I said, things that can be noticed visually. That's why this is more of like a qualitative analysis. There will be some numbers, but please don't get caught up into that. Just try to look at the visual differences of the videos that I'm going to show. First of all, I wanted to start testing the app size. And I know this is not related to performance, but I think it is a nice addition. So the old architecture app has a size of 83, almost 84 megabytes, while the new architecture has a size of 73 megabytes, which is a 15% decrease over the old architecture. And like you may say, well, 10 megabytes is not a lot, but it is a nice addition. And remember that the less space your app takes, the less likely it is to be deleted when the user is low on storage. So when you're low on storage, what do? You go into your applications, you sort them by size, and you start deleting. And I assume that you don't want your users doing that. So it is a nice addition to be able to have apps that have a lower size. The next thing that I wanted to test was the time that it takes for the app to open. For this, I took measurements of 5 times opening each app. And you can see there's a difference. The old architecture takes 2.3 seconds to load from like kill state, while the new one takes only 1.6, which is a 30% less. So I think the new architecture is the winner for this challenge. And keep in mind that the app open time is the first thing that your users will notice when opening your application for the first time. That's what's going to be kept in the back of their minds. So the new architecture improves that significantly. The next thing that I wanted to test was the thing that I said about the bottlenecks, right? So what I did was I created a button that when you pressed it, it triggers a modal. But at the same time, there's a heavy flow of data, like a really big object being stored in the async storage. And what I tried to do was to like clog the bridge to see if it would hurt the performance of the modal. You can take a look at it. I don't see a big difference. Maybe I think that the old one is a little bit more sluggish, but then maybe wishful thinking. What I do see, though, is that when you close the modal, both go down at exactly the same time. And that is expected, right? Because I didn't do the heavy flow of data on the closing action of the modal. But still, I think the results might be inconclusive. So nobody wins this round. Another thing I wanted to try out was what would happen if a user started typing in really fast and like there were many re-renders going on the screen. So for this, I downloaded an auto clicker and I just started typing 1, 2, 3, 4 with 100 millisecond delay. So this will be like a really angry user. If your app does not incite rage, maybe this won't happen. But you can see that, well, the first thing I noticed is that the old architecture, for some reason, starts making some numbers smaller. I don't know why, but I thought it was my mistake, like some styling issue or something, but the new one doesn't do it, so I thought I'd mention it. But what's really interesting is that you can see that both start flowing quite nicely. And then when there are a lot of numbers, the old architecture starts struggling a lot and dropping frames and everything being kind of, oh, no, I didn't want to do that. Well, the new one holds up a lot better. It still has some like catch-ups and stuff, but I think, surprise, surprise, we can give the crown to the new architecture for this particular experiment. And you know, as technology advances, your users will not only like your app better if it performs well, they will expect it to perform well to use it. So we have to adapt. Another thing I wanted to test, and you may, like as React Native developers, you may have heard like the native developers telling us that, oh, but you know, the React Native is awful because when you have a long list, and you scroll really fast, some things do not load at all or take like 3 seconds to load. And we were like, well, but it's native, it's like a hybrid approach. You can show this to them. You can see that that happens in the old architecture, but it doesn't happen on the new architecture. So that's great. It still happened to me once or twice, though. So maybe do not say that to them, because you obviously want to win. But I think we all can agree that that side is so much better. So it wins this round. And you know, everything that contributes to your app being flicker-free, smoother, makes it feel premium, makes it feel more polished, and makes it something users want to use. Another thing I wanted to test was gestures. What would happen with a pan responder, and if it would be any difference. You can see that I have a view. The green dot is a view with a pan responder. And the white dot is like the actual position of my finger that the operating system is capturing. I cannot, to be honest, I cannot see a difference in the video, like in the spacing between my finger and the view with the pan responder. I took out some frames, and I cannot see a difference either. So I think that for this particular case, the bottleneck may be elsewhere. Like maybe it is something, it has something to do with the low-end device that we picked. Well, the last thing that I wanted to test was what would happen if I render a huge amount of views. So I decided to render 1,000 views and see how much time it would take to render in each side. So this is a pretty big difference. You can see that on the left side, the old architecture takes 3 seconds, again, on average of 5, to render the 1,000 views, while the new architecture takes only 1.9 seconds, which is a 37% decrease over the old architecture app. So that's a lot better. And rendering is everywhere in mobile applications. So knowing that the new architecture renders faster, you know that your application will be better. So that was the end of my useless experiment. I wanted to sum things up a bit. Well, I can assume that you will agree with me that we can proclaim the new architecture as the winner, right? There are also many other things that you can test that I did not test, but that will surely work better on the new architecture. But will this make a difference on your app, though? The answer to this is, I don't know. Maybe not. Maybe it will, but I think, well, first of all, if you're trying to convince like a client or a product owner or your inner voices to update, maybe you can show them these results, and that could be an extra reason. But mind you, I was looking for this. Like, I tried things that I thought would perform better on the new architecture because of the changes that I read the new architecture introduced. So maybe your application does not have any of these bottlenecks or these issues. And if you're having performance issues, maybe they come from other places. There's no way to know, well, there's a way to know that. You can like use a profiler or something. There's no way for me to know your specific cases. Should you still update? I think you should, because as the React Native documentation states, enabling the new architecture is opting into the future of React Native. You know, I mentioned like the native developers telling us, oh, React Native doesn't perform as well. And all this work that the React Native team has done to get this new architecture out is trying to make the gap smaller between native and React Native. We all know the benefits that come from hybrid development. And having each time a smaller gap makes those benefits sometimes outweigh the performance benefits that come from native. So I think you should update to bet into hybrid development. You should update to bet into all of this community. Thank you.